I'm so happy to have opportunity to share with you a personal journey. And this not just my personal journey, it's intellectual journey and my learning experience on this. And I think you can benefit from it as well. Okay. And so that's given I have PhD in finance back in, I got degree in late 80s. So I mean, that's a completely different era. I can talk about natural language processing today. That means that you can do it too. So it's a mindset you need to have. Okay. If you have any burden, I mean, we all carry baggage, right? Because part of our training, our going up. So if you have any of those baggage, trust me, I have even heavier baggage. Okay, I have to shake loose in order to embrace this new thing. Why you shake loose does not mean you abandon them. You integrate them. We human as integrator, okay, you can take advantage of instead of treat it as a disadvantage, turn it into your advantage. So that's what my talk is going to be about. First, I'm going to cast the issue in the way most data scientists won't be able to tell because they don't have that kind of background. They don't have that kind of domain knowledge. So what I'm going to be talking about is real finance. Okay, I don't mean to criticize other people. I'm just telling you the fact. Okay, a lot of data science or the kind of natural language processing usage are sort of mundane usage, nothing to do with finance really, right? There's something being used in financial institution does not mean it's finance, right? Okay, so today I'm going to be talking about credit in a very deep way. Okay, credit risk analysis, portfolio, and thinking about how this issue, that does require some domain knowledge, right? So I cannot expect to understand fully. I'm going to sketch out. But in that framework, then we think about what natural language processing can help. That natural language processing, in a way, is not to replace, it's to complement. We don't expect them to contribute as like a wholesale replacement. We expect them to contribute as incremental piece. Okay? So how do we think about this problem? Dictate how we approach with the solution. Okay, so I hope today the takeaway is that you get that understanding. Oh, there's something natural language processing can be used in a very deep way in finance. Okay, so integrated with the most modern credit system, because that may sound like a bragging, but some people know about CI. Know it is the most advanced system in the world, right? So we can add a natural language processing component to it to make it even better. Okay, so it's a complementary. It's not meant for replacement, and you can see that it cannot be replacement. I would convince you. Okay, so the first part, it's going to about this credit analysis, how natural language processing can come in, and what kind of performance improvement you can deliver. So the second part is going to be about how to actually extract the sentiment for this particular purpose. Not extract sentiment in general, extract sentiment out of the ocean of documents for that particular purpose to complement. Okay, so what you have learned for this day and a half, and the things will serve in a way as a background, because we're going to be talking about aspect sentiment, right? Okay, and we're going to talk about LDA, right? Because we have to use it, and all this for obvious reason. You'll see that, and I learned these things from reverse engineering perspective, because I have a task. I try to figure out how can I accomplish that? What can I accomplish that? And dig deeper and deeper, and then you start realize, oh, I made this mistake, I made that mistake. Isn't that just learning the journey? So that's, I think that part is also worthwhile to share with people. Because of the first problem when I had years or so ago, is I didn't even have a sense of direction. And I don't know where to begin. Okay, and I think that's bother a lot of people when they start something, right? Don't know what to begin. I got a problem. I cannot even articulate. Okay, needless to get help. In order to get help, you must be able to articulate your problem. You know what I'm saying? Right? Being able to articulate is a tremendously important asset of skill. Once you are able to articulate a problem, I bet you can find solutions because someone can solve it, can help you with that. not being able to articulate, I think that's most people's problem. Right? Or the frustration, social frustration. Okay, so I'm going to share with you. Now, if you sort of know Chinese, that's my Chinese name. Particularly, I write it out because that's my English is not Hanyu Pinyin of Chinese. So anyway, so let's try to have a productive session. So here's the outline of the talk for this first part, then our second part, right? After break, we'll talk the second part. So here I'm going to just tell you the result, and the issue had to be considered. And once we do that, what will happen? So I'm going to show you the evidence, right? Okay, then I come to say how the sentiment is created for this particular purpose. Okay, so credit analytics in perspective. I'm going to sort of describe to you. You look at the credit risk. What is the right perspective? I would say that's only right perspective. If it deviates from that, I will sit down and argue, convince you. If you don't get it, most people. So far, I offer this many times. No one ever argue with me afterwards. They only have not thought about it. It's completely natural and obvious, but people don't think about issue that way. Okay, so I would say you think about credit risk, you should think in this perspective, and it's tremendously valuable for you because you can actually see the issue and then what kind of service you get. So credit analytics perspective. Now I'm going to talk about deep credit analytics in action. That's credit research initiative. Some of you are involved here, right? And that will set the stage for why we do sentiment analysis. So we're going to construct the credit focused sentiment. You see that? I notice that? I know that one. Credit focused sentiment. I'm not saying other focused sentiment is not important. It's not for this. I'm talking about credit. I want to extract explicitly credit focused sentiment. So that's what I'm going to talk about in some of the general things. Then I'm going to show you the evidence, okay? The incremental power of it. And finally, I'm going to give a case study. Okay, then we move on. Okay. So jump in anytime for people here or people online. Okay. So if you have a question, any clarification, just stop me. Okay. So I would say it's a few key elements you always think about. Granularity. When you talk about credit risk, it's basically saying the party which owes you money not able to pay, not able to pay in full, right? And what kind of measurement you want? Definitely it's not classification. You want to know the probability of not getting your money. What you want to classify? And there's technical jargon for this in a business called granularity. You deal with debt, you deal with interest rate. Interest rate doesn't say you pay me interest rate A, interest rate B. They're talking about 1.275%. Right? What do you want to think about credit risk in the sense of ABC? You must go granular. It's silly not to go granular. Okay? That's the first element. So forget about classification tools. They're not particularly useful for credit analysis. And yet, today I'm going to use a classification tool. I'm using it as a complement to add something to the information, okay? But the target is not to classify credit. We call abigo, people owe you money. It could be legal person, it could be natural person, right? The probability of that party not paying you, you don't want to classify them. You want to know the probability not paying you. The tool of accomplish this task could be classification. Yeah? As one of the in between whatever step. But the final goal is never about classification. Okay, if you use this first criteria, you look at what is out there. A lot of people try to peddle you classification. I'll tell you, if you get that result, it's crippled. This doesn't serve your end purpose anyway. You can feel good for a moment, but it doesn't serve your purpose, real purpose, the granularity. The other one is the turn structure. Turn structure meaning what? If you fail to pay me with 1% of probability, over 1 year is different from over 3 months. That's called turn structure. So if you fail to understand this, just think about interest rate every time. No one will lend you money to say, okay, I just lend it to you. For how long? No need to specify. They'll tell you 3 months, 6 months, and or longer, rate is higher, right? That's called turn structure, right? How can you think about before not thinking about turn structure? You classify people A, B, C. Not only it's not granular, what's the term structure? Okay, you must have a term structure. Then the other one, you must think about default correlation, because you don't lend to just one person. Your parents may only lend it to you, but lending organization don't just lend to one party. It's a portfolio, right? So in order to think about portfolio, you must consider, oh, maybe they two will default together. That's called default correlation. Yeah, you three will be defaulting together as a default correlation. Default are correlated. So think about it. What classification can do for this, right? You understand my point now? The other one, you must ask yourself, how these default risks are linking to the fundamental risk, the source of risk, like exchange rate, commodity price, weather, or something causing things, right? In fact, that's a source of default correlation anyway, because we all hit by COVID-19, right? You know, the source of correlation is coming from common factor. So this system had to be related to some sort of common factor. Otherwise, it's crippled. Yeah, it's a crippled system. Look, managerially, you know, if you're a manager, at least to just prove your importance, you always ask questions. What if this? What if that? Right? So this allows you to think about scenario. Okay, if exchange rate tank, what will happen to this? Right? If a commodity price goes to the roof, what will happen? That kind of question you will ask, unless you link to the risk factor, how are we supposed to be able to address that? Yeah, particular common risk factor, right? If we have a recession, what will happen? You know what I'm trying to say? You understand the idea now? So in order for, before we even charge ahead, we had to think about the system with those components in a consistent fashion, that integrated. Okay, then we think about whether we can improve that system, right? Incrementally improve that system. If a system is perfect in doing something in sense, the system can still not accomplish this task. So you end up a piecemeal solution for this and that, that's inherently inconsistent, incompatible. Okay, so that's, I would say, you know, once you have this understanding, it will help a lot. And for credit analysis, right? So that's very domain specific in this sense. So corporate default prediction is our focus. When I say corporate default, I'm telling you, I'm dealing with a legal person only. Does not mean a natural person are not important. Those are consumers. You can think, you can sort of imagine the attribute which determine corporate default are going to be very different from individual. Like your salary is important for your default. Your salary is not going to affect corporate default. Right? Your education does not affect that corporate default. Corporate are legal person. So today's focus on legal person. Yeah. I'm only talking about legal person today. We try to model legal person, try to accomplish that whole thing, and we're going to add a natural language processing sentiment to complement this existing system with all these components. Yeah. Okay, is that clear? Okay, so there are a few concepts I want you to have. One is a probability of default. Because the corporation are limited liability, so in other words, they walk, right? When they no money paid you, company is yours. Debt holder, you can take it, right? That's called limited liability. So we are talking about probability of that happening over a certain defined time period. Now, your defined time period will be different from my defined time period. For people in the lending business, know, if you're in trade finance, you're short-term looking. Your customer, your client is always short-term because they are financing this inventory and not inventory, I mean the trade finance, right? The bills, right? Invoice. And for some people lending like 5 years, they think about longer term, right? So your horizon is not my horizon. To say your horizon more important is silly. We system had to be accommodate that, right? Okay, so different horizon. And so we have to think about probability of default. That has to be time dependent, horizon specific. Time dependence today is different from tomorrow. Had to be entity specific, means Abrigo, in this case, corporation. Had to be time dependent, had to be horizon specific. Okay, so there are all these aspects, right? It's a natural aspect. And the other thing we must consider in order to have a system is a company I call POE. is the probability of other corporate exit. You think about merger acquisition, it's going to happen, right? And in fact, the merger acquisition data shows are much more likely to happen, right? About 10 times more likely to happen than bankruptcy and default. Why is it important? If a company has been acquired by another company, this company is not going to default. They exit, but not for reason of default. Okay, unless you control that, you never will get an analysis right. Other corporate exit. You want to get fancy, you can classify other exit to different sort of subcategory. Yeah, but for default, at least you have to consider one catch-all category. That is, they leave for reason other than default to distinguish them from survivor, right? Get that? At least you have the three categories. But we're not going to use a classification tool to do this. We're going to just think about probability of occurrence, okay? You understand what I'm saying? Okay. But, you know, some of the classification embedded is a probability, but they're not probabilistic in a sense, okay? It can sort of pseudo probability look like a probability. Look like probability is not a probability, right? Okay. And we're talking about actual physical occurrence. And some people do classification, they tell you to balance the sample. What a bad idea. Because you're deviating from reality. Default is a real event. How do you balance sample? I mean, I hate to say silly. It's silly to balance sample because you're deviating, you walk away from the reality. Unless that probability has no meaning. Has meaning, had to reflect. If it's 1% chance, let it be 1% chance. Okay? If 1/10 of 1%, let it be 1/10 of 1%. You cannot, because of your analytical tool, say, let's twist it, let's balance this sample. Okay. Let's remove from the reality. Isn't that what it is? Okay, so keep that in mind, okay? So I will talk about POE, but that's covered over there. It's a probability of other corporate exit. Think of it as a commercial acquisition, okay? Now, of course, if you think about natural person, in case you ask, what is a POE then? It's also there. Because you have to look at from lender's point of view. You know, if I'm a bank, suppose I DBS, okay? Now, in Singapore, no, what banks to talk about? DBS. DBS, you are actually borrowing money. You are as a natural person borrowing from DBS. What is the exit? When you're not banking with DBS, does not mean you default. You just move to UOB. Okay? From lender point of view, it's exit. Exit from the lending portfolio. That has to be considered, right? Okay? So ever present, you know, for people deal with mortgage portfolio, they know prepayment. Okay, it's not default. It just because of new job, relocation, they have to sell the house. Prepayment. So other exit always exists, okay? Don't ever underestimate their importance. They're very important, right? Okay, so keep that in mind. So in order to think about this, now so far, none of these things has anything to do with the natural language processing, right? Correct? It's a conceptual framework of credit analysis. Okay? Okay, so let's get a bit of mathematical notation so we have a better understanding and communicate. The problem is going to be very high dimensional. Okay? It's nothing to do with the natural language processing now. Because you're going to deal with so many obligors, which are legal person in this case. Suppose it was 10,000. 10,000 is a small number. Because our database is over 80,000. Only for exchange traded. If you include SME, right? Okay. Meaning is a small number there. Right? Okay. So anyway, I'm just using as an example. Suppose you think about it, there's 3 common drivers, just for sake of discussion. Say exchange rate, interest rate, something affect, okay, commodity effect. 3 common drivers. Then you have each individual is characterized by some attribute, okay? Say 5 attributes. Yeah? There's something unique about individual. There's something 3 common. Now, the one way to think about it, you have an 8-dimensional attribute. And that is a bad idea. because you are ignoring the real structure. The real structure in this case is going to be stated over there. It's a 50,000 and three-dimensional problem. Because remember that 3 is common to share by this 10,000. The other one at 5 is every individual specific. Underlying there, they are dynamic. If I break that one, treating as 8-dimensional, I'm sort of ignoring their time dynamic. You understand what I'm saying? Because your leverage, how about your last year's leverage? Huh? Your leverage cannot be related to my leverage last year. It's an autoregressive or memory in your own leverage. Understand what I'm saying? You can think in the data science sense, it will be 8-dimensional problem. And most people, data science are using that standard way. I don't think it as 8-dimensional. I think it as a 50,000 and 3-dimensional problem. If you just do classification, you don't have to think it this way. Just think about 8-dimension. You've done that. After all, just numbers. What else? Okay? But in actuality, we're talking about 50,000 or some dimensional time series. Okay? Okay. So anyway, the other things to take home is to remember, since we do 3 classes, right? In this case, it's a default, other corporate exit, of survival, 0, 1, 2, I call them. So any model we call PDO, POE, it's basically something like that. It's an F function. It's a function of capture this attribute. This X can be very high dimensional, very low dimensional. That X itself determines the performance. When I say think about A, depends how you look at that function. If you really want to have advanced use, you have to think about it as a 50,000 3-dimensional. Okay? So you have a different way of looking at it, right? Okay, the other thing you have to think about this one, it has to be tau specific, means horizon specific, because you maybe think about 3 months, maybe think about 6 months. That T is at the time you look at it, is a prediction time, tau is how far into the future, I is which company, equal 1 means default, could be equal 2, could be equal 0. Understand what I'm saying? However you do it, it's just function. You call it, you use a neural net, it's a function, you use a parametric, whatever, it's a function. The conceptual is a function, right? So, but every function you define it as a set of parameter. You call it parameter or not, it's a parameter. If typical neural network, this will be in the millions, thousands at least. Right? Very simple net can be thousands, right? It's still parameter. Now here's a problem. I think a lot of people have a baggage like I have. I have a hell of difficulty to accept neural net conceptual. I say the theta, my statistical training tell me is a theta, it has to be identified. Okay, I can never accept alpha plus beta to be 5 and to leave it as alpha and beta. I had to call it alpha star equals 5. Because alpha plus beta equals 5, it will not pin down alpha or beta. You understand? Statistical trend people, they instinctive reaction to things. It's disidentified. Or econometrician, it's disidentified. Neural net is never identified. They don't even think about that issue. And you're gonna have a difficulty unless you so, okay, forget it. And that's not how they think about problem, okay? Okay. Now, once you sort of think it's identified, mathematician will tell you, now you have a chance of having optimization. Otherwise, you cannot even optimize. Because if you leave it as alpha plus beta equal to something, you can never optimize alpha beta. Because a garden variety combination is the same result. What do you even want to optimize? Unless you make it identifiable system, what do you want to optimize even? Okay? So that is a lot of people have problem. I have a problem. I look at the neural optimization. Every time I look at that problem, even today, instinctively, I don't like it. Because I say, you got every kind of solution, you really have. They don't. Right? Answer, it's everybody's guess. Therefore, since I'm talking about it, I will just say, therefore, neural net mostly, even what people tell you, I would personally say, don't believe it. It's not interpretable. It's not identifiable. It's not interpretable. Because story can keep on changing and result is the same. So our identification, that's why statisticians are so insistent to have identifications, right? Because otherwise the story keep on changing. Oh, alpha is big because alpha is big. No, alpha is positively big. No, I turn alpha into negative. Oh, negative now, change the direction. How you ever be able to interpret? Philosophically or scientifically, it can never be interpreted unless your identification, right? Do you understand? Okay, that's scientific truth. It's okay. And people can say whatever they want. That's the scientific truth, right? Because story keep on changing because the outcome is the same. So what's the point of talking about the story of driving? Unless the story itself is not important to the problem. If a story is not important to the problem, it's okay. If a story is important to the problem, it's not okay. You know, that's why you think about from managerial point of view. Now I have a better and better appreciation of managerial point of view because I also have a company. If you think about that, if unavoidably you always think about story, right? Because you need to justify to yourself, you know, justify to your boss, you know, justify to your clients. You need to explain. Okay? You must explain, right? And without identification, practically or conceptually, it's not explainable. It cannot be explained. Period. Like it or not. The other thing I think is that's one point of awareness to think about this kind of issue is term structure I mentioned earlier. When you build a model, don't you think that had to be obeyed? In other words, I say default probability over 3 months. The other one default probability over 6 months. Over 6 months had to be greater than 3 months, right? Otherwise, it's self-inconsistent. Today, I'm looking at DBS default. I'm not saying DBS is going to default. I'm just saying there's probability. If I have a model talk about DBS default over 3 months, I contradict myself if a 6 months default for DBS today is actually less than 3 months. Believe me, if you do it, you don't put a constraint in there, your result will have a high percentage of not obeying. That itself already tells you the model doesn't make any sense, right? So in other words, these are kind of domain knowledge when you do this, you have, right? Yeah. When you do classification, all this will be gone because it won't even be an issue, cannot even be answered. Understand what I'm trying to say? It cannot even be answered. So you have to sort of go back to the original setup or face the issue head on. Okay, so interpretability of the model is always important, but that has to be something you keep in mind. Okay, it's important to use it for sure. Okay, and so no universal answer. The answer had to be task specific. Okay, let's keep that in mind. And then there's identification issue. And quite often it's quite vital. But in some circumstances, it may not be vital. The usage doesn't cope. Okay, then the other thing, neural net or any other tool are for interpolation. It's never meant for extrapolation. Okay, it's just smarter interpolation. Interpolation means that never even try on something data has not covered. Because it's crazy. It will give you crazy. It's not speculation. It will give you crazy. Okay? Because the flexibility, lack of identification. Now, if I use a linear model, I say response to your income is positive. Even at some income level, it may not be quite correct in magnitude, but the direction probably still right. Yeah? Okay? So for extrapolation, you really want to have understand the system. If it's just for interpolation, it's fine. Keep that in mind, okay? The model for extrapolation, don't use a neural net or support vector machine. Those things, just don't use it because they will create problems. Seriously, okay? Dynamic independence. When I say dynamic dependency, it's slightly different from what earlier been discussed, a temporal relationship. You can call that dynamic dependency. I'm thinking about dynamic dependency in the way we traditionally understand economic finance, like a cycle, business cycle, credit cycle. You know what I'm saying? There are lots of phenomena, and they have been really studied for a long time. We have a lot of knowledge. And why do you want a black box to treat that? And in fact, you know, understand? It's like we want to reinvent the wheel, ignore what people have learned for years. Right? And some of the dynamic economists tell you their endogenous system, they are constrained. Okay? Like GDP and unemployment and the things that work together. Is they are not like this is serious, that's serious, independent. Okay? You understand what I'm saying? So there's a wealth of knowledge may build out over there. That dynamic dependency, we want to utilize that, right? That's why we're trying to say earlier. That attribute, we think about 5,000, 50,000 and three-dimensional time series. Then you're allowed to look at that, right? Okay. So anyway, so these are the sort of bit of modeling choice, okay? And some become very important, some are less so. So let me comment on a few things. Is more data better? Yeah.
So I'm not regarding this dynamic tendency. So for many people, prediction or so they consider this scenario, different scenarios. So for example, to predict the GDP growth, you have so many tendencies from other scenario related analysis to understand that. So I'm not sure whether this sort of idea can be applied.
Okay. There are certain circumstances you can mimic in other ways, but I give you an example. You will definitely agree with me. Okay. Suppose I think about autoregressive model. Okay. AR1. I'm not saying it's good model for certain series. Suppose that's the case. And that model is built on the quarterly series. You can actually deduce that for year, right? According to the model. Now you say I can also directly do some sort of 1 year prediction. If that's for prediction. Prediction is not the only use of. And for instance, I want to study, as an example, stress testing. If GDP go down so much, I'm not talking about prediction. I'm talking about conditional prediction. And that's what scenario analysis really is about, a conditional prediction. In that case, unless you have a model, you cannot generate future. You understand? You need a model to generate future. Neural net is actually not even a model for generating future. If you take AR1 model, you say prediction, you can do prediction. Oh, my neural net does better than AR1. I say big deal. For this purpose, maybe that will serve that purpose. If I don't care about reason, that's good. But if I want to generate future scenario, my AR1 can generate, you cannot. You understand the point I'm saying? So describing future, not necessarily just for prediction. So dynamic model, when I say dynamic dependency, I say in a broader sense. You really want to know the dynamic. Now we know every time we commit to a model, you are prone to make a modeling mistake. But sometimes that's a price you have to pay to have a reasonable model, right? Okay, so that's what I meant. Dynamic is actually very important because once you can describe the future, then you have a chance to zero in. You see that many of the scenario, like a central banker quite often will say, like a Chinese government keep on saying hitting 7% GDP. That's before COVID-19, right? That was their policy objective. They never say how to hit the 7%. They can take all kind of paths, so long as annually hit the 7% as a policy objective, right? Correct? And how you use a neural net to do that? I mean, in other words, you had to use the model of drivers. Okay? You cannot just view it as a prediction. So anyway, so there are many instances you need to do that. So my point about this one is that more prediction, more data is not necessarily better. Quite often we think it's better, right? There are two reasons it's not necessarily better. Okay. Let me talk about positive side first. More data are likely to get a better model, right? There's more data. Okay. But the more data, it may get a what? more missing data. So I'm talking about predictive variable. So you go back to my issue, Y and X. I get a more X is one thing. There's no more Y. More Y means what? I already have a 0, 1, 2, 3 category. When I say more X, I'm talking about more predictive variable. So let me sort of give you a concrete notation so there's no confusion. N and P. N is number of data instances. P is a dimension. Y's dimension is always 1 with the 3 labels, 3 outcomes, right? 0, 1, 2, right? But X can be 1,000. Right? More data in terms of P become bigger. That's one thing. More data in terms of M become bigger. That's another thing. I'm talking about P is bigger. Yeah. So when you have a bigger P, immediately you have more missing data. You create some variable, like for instance, today I'm going to suppose I'm going to predict IBM from news article. Okay. So I create a field, I'm having the sentiment about IBM. Oh, I do not have a sentiment about HP. That's missing data, right? Correct? Because under that sentiment column, IBM, I'm able to fill in a number. I don't have a number for HP. There is no media coverage on that day. So lo and behold, you have a bigger missing data problem. It's a structure. Don't hide, don't try to avoid it. Right? You got a bigger missing data problem. Is that clear? So you have to treat missing data. That's for sure you must do. So more data is not necessarily better. Right? Because your model, you may have an even bigger missing data problem. Okay, that's one thing. The other one is more data instances. That means M become bigger as opposed to P become bigger. That most people will say is better. That's not even so. Don't forget the data you get are time series data. That's in finance, what I'm talking about, right? Goes longer, you get more data. There's always a structural break in the system. Before COVID, after COVID, more data. You wish COVID didn't happen, not because they've been constrained when traveling. And from data science point of view, structural break, right? I'm mindful of that, right? Okay, so yeah, it's in general, it's good to have a data, but more data, but not necessarily so. You really have to pay some attention. In particular, when you get into unstructured data, the missing data becomes more serious. Okay, today, I'm not speculating. Every issue I'm talking about is the issue I'm confronted, right? Okay, we have a huge missing data problem. We had to figure out how to deal with it. Otherwise, it's useless. Creative sentiment cannot be used. Yeah, I have a sentiment, so what? I have sentiment about some company, but how about other companies? Oh, I'm not going to use that? Or I throw away, in essence, all the structural data associated with those companies. Isn't that the case? Right? Okay, so that we should keep it. Okay, so here is an undertaking which do a bit of promotion called Credit Research Initiative. We started in 2009 at the NUS under Risk Management Institute then. It's basically for credit rating reform. We set out to actually do a more sophisticated system dealing with those traditional data, but they are big data, right? Huge, right? Okay, model with a time consistency, we call forward intensity modeling. Okay, that for garden variety, we do that. So we want to be pushing the scientific frontier. We also want to create public good for credit rating reform. And that is a backdrop of what I'm talking about today, because that's a system, presumably after this undertaking of NLP, great sentiment, we're going to add to that system as additional P variable. Yeah, we're going to increase the P dimension because of the additional variable. If I contribute to the performance, I'll be great, right? I do not know whether it will contribute, right? In the beginning, but I can tell you now, yeah, indeed, okay, and has a very positive message. But anyway, so this is the background. Okay, so all the current variables in the system in the model are basic structural data. What are they? They are primarily for financial statement, stock prices, interest rates. Some are macro, some are firm specific, some are high frequency, some are low frequency. Okay. But you will agree they are very rich, right? These are for legal person. exchange traded firms, they are regular reporting, and their financial statement has been audited too, right? Okay, so they're one type of things. So we had made an effort several years back to incorporate this sentiment, and we failed. And at that time, we used something called Raymond Peck Sentiment Index. I'm not keeping up with Raymond Peck, so I don't know whether they improved, right? In old days, I'm sure they use a bag of word technique. Okay, they come up with sentiment about company, but their sentiment, quality aside, is generic sentiment about company. So company can do good because they contribute money, right, to something good cause, but not necessarily credit related, right? So in other words, the sentiment itself is not very targeted. Okay, and technology may be outdated then. I don't know because current Raymond Peck, you can go to the website, you can still find them, right? They're selling those sentiments. I don't know the quality. Okay, I'm just saying the time we had our Raymond Peck index, the study was done because we have a one person full-time here specialized in Raymond Peck index impact. Did a 1 year, conclusion, got nothing. And if we just use the Raymond Peck index on those companies with Raymond Peck index alone, has some expanded. That is like throwing away structural data. But once the structural data are in place, that Raymond Peck index come in. That's not offer any experimental power above and beyond what we already. Okay, there are two kinds of possibility. One is the index construction is problematic. The other one is maybe the structural data are so rich to begin with, anything of a sentiment just regurgitating what is in the financial statement, in stock prices. No additional information anyway. Either one, both are possible, right? You agree? Yeah. So we don't know. So I don't have a prejudice. We just had conclusion there. In fact, okay. I say, well, I'm going to rejuvenate this few years later. Okay. So about a year or so ago, I assembled a team. We start to look at, and that's the learning journey. So far, that's all background. Okay. But our goal is very different from many other undertakings. We're very specific. I want to create a variable and be adding to the structural model we have in that grand context. Not only we need to be operationalize this, not the research piece, because I can write a paper and forget about its support. We won't be able to on a daily operational basis, keep on producing it. Okay? Not just a research piece. Okay? So that requires a lot. Yeah, go ahead.
Just a quick clarification. When we talk about sentiment, it seems to me you're talking about sentiment of specific company. There's also some people talk about market sentiment in general of a country or the economy. So do you make...
Just save that question later. I can be very concrete to answer you. Okay. And yeah, it is. We had a methodological discussion. We can have more meaningful discussion. So I'm going to address the issue very methodical. Okay. Okay. So anyway, the current system covers about 133 economies with 80,000 firms. Okay. So in my wider stream, it's to cover all of them with a sentiment as well. But I know it's unlikely to happen. So for instance, we start out with English language. So we probably can cover some. But all these pieces are separate model anyway. So it's incremental progress here, incremental progress there, right? And we're working on Chinese language too. Okay, it will affect something. Then English language probably can be used for India, right? But not necessarily in some other economy with little coverage of English, right? Okay, so anyway, there are all these operational reality, right? So it's incremental in that sense. Right? Now, let me show you how the structural model can actually perform. Right? Some of you may have seen it elsewhere. So as lay out the background, okay? Structural model is actually very powerful. When I say structural model, I don't mean structural because people get confused. In the credit literature, there's something called structural model. I don't mean that. I mean using structured variables. Okay, that means data science terminology. Okay, that naturally original numerical. okay, like a leverage, those kind of numbers. So when you use that with a proper technology on transforming from get Y related to X function, here's an example of Lehman Brothers leading to its default. These are probability of default. Okay, it's a 1 year probability of default. I can plot out 3 months, I can plot out 5 years, right? This is 1 year. On the vertical axis is a log scale. Every tick is 10 times larger. Okay, the maximum probability default can be 10,000 basis points. That's 100%, right? That's a basis point in log scale. Horizontal is 3-year time period leading to Lehman's default. And Lehman Brothers defaulted in 2008, right? September, okay? And all other those lines are credit rating companies rating. Because Lehman is a big company, so a lot of ratings, right? So what we over there is a Dominion Bond Rating Service, Moody's, S&P, okay? Look at them, they're literally flat, all of 3 years. And the quantitative model using structural variable is already indicating probability of default year ahead of time on several hundred basis. That's a huge. Now you may wonder 100 basis point, that means 1%. Large, now triple B company is about 0.15%. Okay, so 10 basis or 15 basis point range. Okay, for the sake of discussion, we just say 10 basis. Okay, 100 basis points, 10 times big. Yeah, than triple B company means worse, right? Okay, and very quickly shot up 1,000 basis points. That's a 10%. And a few days before, you can see that it's reaching almost 10,000 basis points, almost 100%. And the rating was still A. Okay, so you can see the quantitative model. This is actually done on our sample basis. It's not a looking back. It's a rolling using data up to that. Yeah, you know what I'm saying? Okay, so anyway, so you can see the model can actually do wonder, and you can actually produce probability of default, which is ultimately we want, right? Okay, it's highly indicative. In this case, how much you can improve? I mean, just think about how much you can improve with sentiment. And there's little room for improvement. But there may be other cases you can actually improve, right? You understand what I'm trying to say? And so you want to think in terms of incremental, otherwise you will be disappointed. It's incremental. Now, I have a personal view on this. I think the technology I'm showing you today is even more powerful on SME because those are weak in structural data. Whenever structural data are weak, these are going to be more powerful. When structural variables are very strong and highly informative, this contribution is going to be weaker, right? So natural, right? Okay, that's what I want you to understand, okay? The structure, the variable, as it stands now, properly modeled, it can do wonder. Okay, that's how this power our system. And we've been using this system. A lot of users, IMF, and many financial institutions use it. Okay, so we use something forward structure. So I want to sort of share with you this understanding. You will find it, I'm sure you'll find it useful for your thinking. Something called forward. Forward structure is this. You can think about default just like a forward interest rate. What forward interest rate means? Suppose we fix the duration of 1 year. Duration means from the time of looking something go on for 1 year over that period. That's called duration, length of time. That's a standard finance jargon, right? Duration of the financial instrument. Now, forward means you look at that into the future. 3 months later, I look forward for 1 year. That's a forward starting 3 months from now. You can 6 months forward start to look at for 1 year. Why this is important? People use that to think about the interest rate direction. They are deducing from the term structure of interest rate into the forward rate. So since we model term structure of default, we're able to have forward rate as well, forward default rate. So in other words, I can stand in here, think about 3 months later, what Lehman will, what's probability of Lehman's default. I can think about 6 months later, what will be the probability of Lehman's default over next year? You understand that idea of forward? Okay, so why I'm doing this? Because it can actually pinpoint the problem. So this on the left-hand side is a Lehman Brothers forward curve vis-a-vis other means a US bank in gray, then there has a yellow, that's a Bank of America as a reference. These are their forward curve. The vertical axis is a basis point, much smaller, 70, 80. Why this is a 1 month? Okay, in other words, I forward start 3 months later for 1 month. Forward start 1 year for 1 month. Duration is always 1 month, but I'm looking at a future point in time, at very still point in time. Just like an interest rate, you lend for 1 month, but I lend it to you a year later. I lend it to you 6 months later. That's a forward structure. Duration is fixed. You understand? Why do we want to do that? We want to look at the default probability when default is more likely to happen in the future. Okay? So the forward curve, this is a June 2008 calibration result. Okay? We look at it, Lehman's default. And this is a 3 month, left-hand side, 3 months before Lehman Brothers bankruptcy. Okay? The curve point at the 6 months as the most likely point. From that day. Okay? So that's a June 2008. That means 3 months before Lehman's actual default. The curve actually say 6 months later. That's the most likely point Lehman going to default. Vis-a-vis other, much lower. You see, the 90 is a huge number because that's 1 month. Of course, you should not multiply by 12, okay? But roughly, okay? Roughly, yeah, go ahead.
Does it also mean, so because it's a curve, and let's say after 24 months, the probability is lower again. So if it survives that first point.
Okay, it's a good point. And what happened is that once it survives, and what forward means, right? It's a, forget about previous period. If it survives that point, think about default. Therefore, it will go down. In other words, the default is more imminent. But once they survive, think about it. If you already default, you're gone. If you survive, you improve, right? So it's very natural they behave like that, right? Okay, that's what full curve. The point is you illustrate compared to others. It's very clear, Lehman. That was 3 months before. It's 24 months before its default. And literally take us to 2007, right? 2006 actually. 2006, it's already telling you. Yeah, what it's suggesting is about a year or so away. Okay, this is the model we are working on. We try to improve this model. So it's not, we're not happy with the model, okay? The model is actually very powerful. We want to add, it's in search for better things, right? Science or whatever, we're trying to do it better. Okay, particularly maybe some instances, the structural variables are not as informative. Maybe they can really help, right? But on Lehman, I think it's very hard to improve, right? Okay.